I'm revisiting this project where I'm using a circuit to replace a TurboGrafx-16 gamepad controller, where I'm following a schematic of a gamepad controller I got on a certain website. And the main functioning part of this circuit is a 74HC157 chip. I just got those in, so I built this circuit here. There's the chip and a couple of resistors and capacitors and the 8-pin DIN connector that is used to plug into the TurboGrafx console. I already did some experimenting on this, but since I didn't have that chip, I simulated how the chip works by using a few other chips just as a little test. And for a quick review of how this whole thing works, the gamepad has 8 buttons, including up, down, left, right, select, run, and buttons 1 and 2. There's also switches for turbo fire, which can automatically press buttons 1 or 2 on repeat. That's using the chip on the bottom, but we're not worrying about that for this project. Since there are 8 switches, they are connected to this chip in 2 groups of 4, and each switch has a pull-up resistor, so when the switch is pressed, it goes to ground. And this chip will take those 8 inputs and send out 4 of them at a time on 4 data pins. And the bank of 4 inputs that get sent out at any given time is chosen based on whether a select pin is high or low. So when select is low, everything connected to A, so 1, 2, 3, and 4A, gets sent out. When select is high, bank B, so 1B, 2B, 3B, and 4B are sent out. So TurboGrafx controls whether this whole chip is enabled or not, and which bank of 4 it wants to be reading at any given time. When I did the previous experiment, I didn't want to have to hook up so many buttons, especially having to have external pull-up resistors as well. I just needed to really test if I can get a circuit to work with TurboGrafx. And now that I'm using the proper chip, I'd like to test it more thoroughly with all the buttons, so I made a PCB with today's sponsor PCBWay with 2 analog joysticks in case I ever want to use those, and 12 push buttons with onboard pull-up resistors, which I'm going to use for the TurboGrafx experiment. So the way this board works, I have a bunch of header pins along the top, so I can just plug in to a breadboard and have all of this free space available to work with this. And I have VCC and ground pins here because ground will be what gets connected to a certain switch output when it's pressed, and VCC will be where the pull-up resistors are connected. So when I put a jumper onto one of these switch pins, it's going to have a pull-up resistor to VCC, and when I press it, it's going to connect to ground. So I arranged the left and right bank of 4 as an up, down, left, right D-pad, and then the 4 in the center are just as a square, so those can be things like select or start. But I plan to use this for general things as well. It's convenient to have a bunch of buttons available. And these joysticks also have buttons, those go to header pins. And we have a horizontal and vertical axis, so for each joystick I have header pins for the 3 pot terminals for the vertical and the horizontal on each. So on this potentiometer from end to end, it's 9.8 or so K because it's a nominal 10K pot. If I go from an end to the wiper, half of that, 5K, and this is the horizontal pot. So if I can push this over, I can't hold everything very well, but it's around 12 ohms in one direction. Then if I pull this, 9.7K or so on the extreme end. Back to center, it's 5K. So I can use those as quick access potentiometers or as actual direction controls. For example, if I'm doing motor experiments, I can have forward, reverse, and speed up, down, things like that. So I figured a board like this could become very useful. So I'm going to hook up these switches and get this on an oscilloscope and then try it out on a TurboGrafx. It's hard to show this, I don't want it to fall apart, but buried down here in these DuPont wires is the 74HC157. There's the 8-pin DIN connector with the cable going to the TurboGrafx controller input, scope probes, and these wires going to the joystick and button board. So here I can press up, down, left, right. Then I have select, run, and buttons 1 and 2. On the scope, I'm only going to be looking at one data output that goes to the TurboGrafx, and that data pin contains information on left and run. So that's activity we're going to see on the scope. The TurboGrafx gamepad port is plugged into the circuit. So if we look on the scope, when I push the left button, you may see some change up in here. And when I push the run button, you'll see a more obvious change. This high is going to mostly be low. So that's the overview. Now let's zoom in on some things. So looking at the scope traces, we don't really need to understand everything that's happening here because I couldn't find information on how TurboGrafx is controlling this. For example, we can see with nothing happening on the game controller, these lines are changing their behavior. Sometimes it's just a single pulse, sometimes it's this train of pulses. But if I zoom out, we have these little blips. That's what we were just zoomed in on. So there's these long periods of inactivity, and then it tries to read the controller, I'm assuming. So if we zoom back in to when something is actually going on, the bottom trace is the enable control on the chip. So when enable is high, it forces, this top trace is data D3 on the controller. It forces the data output of the chip low. Here it just changed behavior on me again. So there's actually a clear example. Enable goes high, the chip is disabled, so the output data is forced low no matter what's happening on the controller. Now it changed into doing this. So if we ignore any time this blue trace is high and the chip is disabled, really this data pin is just constantly high because no buttons are pressed and there's a pull-up resistor on the data inputs. The middle trace is the select pin on the chip. And depending if it's high or low, if select is low, bank A of 4 inputs going to 1A, 2A, 3A, 4A, those are the switches that get sent to the data 0 through data 3 outputs. If the select pin is high, bank B, so 1B, 2B, 3B, 4B are the switches that are sent to data output 0 through 3. So I'm probing data 3, which means I'm looking at inputs 4A and 4B. 4A is the run button, 4B is the left button. So if select is low, button A, the run button, is what we're going to see on this data output. So right here, with no button pressed, I'm going to press the run button and we'll see leading up to this burst of activity before and after. This is going to go from high to low because when we are idle, that select line is low. So the run button is the one sent to that data pin. If I release, the pull up resistor on the switch sends it high. Now if I push the left button, in here we can see there's going to be a change. That low gets wider, and so we can see here when select is high and when the chip is not disabled, right there is where we get our low button press. So that just explains why pressing one of the buttons we get a little bit of change. Pressing the other button we get this more obvious big change. It's just based on those logic control signals. Now the TurboGrafx is on the television. There's no audio the way I have it hooked up. So it's at the title screen. If I press run, it starts the game. And now I can go left, right, up, down, and 2 different kinds of fire. So the whole controller works. And it's hard to play standing on an angle like this, but it's doing everything it's supposed to. And now, as part of a longer-term project, I'm going to take this ESP32, which is flashed with BluePad32, which allows me to use a PS4 Bluetooth controller, and I'm going to see if I can get the PS4 controlling some outputs here that I connect to those switch inputs on this circuit and use the PS4 game controller as a TurboGrafx controller. And now I've got the PS4 controller and the ESP32 running BluePad hooked up to the button inputs on that chip. So I have to join the controller by holding down the PlayStation button and the share button until this light tells me I'm joined. It's hard to do this, especially it's dark right here, so I'm hitting the run button to start the game. And now I can go left, right, up, down, and 2 different kinds of firing. So it looks like I've got Bluetooth control of this. So I now have this one game system being controlled. One thing I still need to get working is diagonal buttons. Right now I'm only able to go up, down, left, right. But that's just a software issue with interpreting all the button presses from the game controller. And I'm still going to work on expanding this to work on other game systems as well. So there's still lots of projects to go with this BluePad32 setup.